welcome. I would like to first mention that we acknowledge that we are gathered physically on the lands of Wurundjeri people of the Kulin Nation, who have been custodians of these unceded lands for many thousands of years. The University of Melbourne is situated on the lands of the Wurundjeri and Boon Wurrung, the Jaja Wurrung people, the Yorta Yorta Nation, and the Wada Wurrung people. We acknowledge and pay our respect to their elders, past, present, and emerging. Hello again, I'm Bahar Salehi. I'm thrilled to welcome you to NLP Meetup after more than 2 years. It's super exciting to see NLP community coming back strong again after COVID years, both in person and also virtually. Before I introduce our speaker, I'd like to mention that we are all interested to organize more meetup events, NLP meetup events. And we are basically looking for more other venues and also other sponsors and of course the speakers. So if you have a venue to show off, like Melbourne data analytics platform, or if you want to sponsor our catering like Culture Amp, or if you have some interesting things to talk about, or you know someone, please reach out to either me, Andy, or Mel. Okay, so I'm gonna introduce our speaker. Of course, I know Andy from University of Melbourne. He graduated right when I started, so he was one of my role models at the time, and still is. Andy got a PhD in NLP before it was cool, which is right, and has spent the years before, during, and since applying software engineering to some combination of research or commercial applications. Currently, he's a card-carrying ML engineer and tech lead of the NLP team at Culture Amp. Please welcome Andy.
Thank you. Okay. So I'm going to do a little talk today about just some experiences building an NLP product with over some sensitive, interesting data sets. It's very much a product-focused talk. There is a little bit of NLP and model building in there, but it's a lot about the stuff around all that, all the actual NLP stuff that's the core of this work. So just a quick shout out to our sponsors. We've got Culture Amp, who is my employer. We're hiring for a couple of ML engineers and a data scientist at the moment. And Culture Amp's provided the catering we've got here. Melbourne Data Analytics Platform provided the venue, and Alta, who pay the exorbitant meetup.com fees. So that's sort of in my capacity as with one of the organisers, and the guy who was foolish enough to put his hand up to speak. So on to the actual talk. What are we actually like? Who are we? Who's Culture Amp? Who is my team? I will explain all of these things. They'll all be revealed to you. I'll go through what we're actually building, and some of the sort of interesting early parts of the project are just like, where do we put the annotations we have to do over this data, and how do we make sure we get them right? How do we like build this feature out for the future? So yes, as Bahar already said, I got my PhD a while back, more than 10 years ago now, which is terrifying. I've worked in biomedical NLP and other sort of facets of machine learning, at NICTA and IBM Research. And then I came to Culture Amp to basically with the hope of building NLP features about 4 years ago. In that time, the number of actual deployed user-facing NLP features I've built is 1. Things happen, like busy product companies, there are always competing priorities, and so we haven't really managed to prioritize that in amongst all the other things that a fast-growing company wants to do. So and one of the things was we were just not in a team that was set up to build these NLP features well. So that has all changed recently, as I'll tell you about in a moment. But just a bit of background on the company as well. So some people may have heard of Culture Amp, some people may have used it. If you haven't, or even if you have, you may not know about all the things that it does. So there's a bunch of different parts of the platform, and we keep inventing new ones as well. But kind of the 3 chief tiers of this at the moment are all around like the employee experience. Can people see those slides okay? Do we want to turn the lights off as we talked about before? Or do people, is that fine? Lights off or on? Off. Oh, magic. Is voice activated? So yeah, it works well. So Culture Amp is the tagline and employee experience people love. So it's all about we sell products to companies who want to make the experience for their employees better in various ways. So engagement surveys, that's the part that's been around for the longest time. You've probably done these even if you haven't done a Culture Amp one, where you fill out 1 to 5 rating questions of I'm proud to work for Culture Amp, or I still see myself at Culture Amp in 2 years' time, those kinds of questions. The interesting part from an NLP perspective is there are also lots of comments that people leave on those surveys. So there's some fun opportunities there. There's the Perform part of the product, which is performance review management solution, where people can give feedback to their peers, where managers can give feedback to their direct reports about how an employee is tracking and what they can do to improve. There's lots of free text there because they have free text answers to structured fields and structured questions. Sorry, and then we've got other parts that we may touch it someday. This develop part of the platform, where we have career development plans that employees can create for themselves. And so, as we'll talk about later, like most of the things I'm talking about today are targeted at the Perform part of the platform. So the reason that I'm actually able to talk to you today about something that's vaguely interesting in the NLP space is that we've actually just spun up an NLP team. If you're nerdy about like team structures of companies, we're calling this a complex subsystems team rather than owning an end-to-end slice of a feature that a user sees from the sort of HTML front end through to all the back end stuff. We're owning just the interesting back end. Sorry, it's all interesting. We are owning the back end model parts of it, and then we supply those services to other teams. That's the plan anyway. So the hope is that now we've got that team, we can actually make some ground on actually shipping these features, NLP features, out to customers, because people really want them, and our competitors are building them as well. But we've started off pretty lean. Most of this work I'm talking about has happened over the last 4 months or 5 months, and we've been pretty lean mode there. Basically, 4 people in the team. There's me, tech lead. There's a data scientist, product manager. They are really important and useful, and then a little bit of front end time, and a delivery lead, a third of a delivery lead who helps us make sure we actually ship things on time and do nice things with our Jira boards and all those kinds of things that delivery leads do if you've worked with them before. Okay, so on to the problem we're solving. The first interesting NLP task that the NLP team has actually picked up. As I mentioned before, it's in the feedback space. So there are 3 important types of feedback we have in the performance platform. And so we've got feedback from managers to direct reports. We've got feedback from peers. You may have done some of these kinds of feedback yourself in the past. And we also have a self-reflection process, which is basically giving feedback to yourself. So the problem with all of this is that actually giving really good, high quality feedback is actually hard. It's a skill. It's not a skill that everyone has. The things you want to do is like often you want that feedback to be actionable. You want to show that there's some evidence to back up the feedback that you're giving, and you need to find some time to actually do it correctly. And you know, you're going to have to ramp up your skills to do that, especially if you're a new manager suddenly having to give feedback to you know, 3 to 10 direct reports that you might have. You know, actually, it's quite a stressful process for a lot of managers as well. So the idea with all this work is about using machine learning and NLP to actually detect whether people are giving good feedback, and then if they are not, guide them on how they can improve it. So basically, can we steer people towards giving constructive feedback, and does that can we steer them successfully and successfully detect whether it wasn't constructive, and then we've now made it constructive. Slight caveat here is that I'm talking about an unreleased feature, so some of the things I'm saying to you are slight lies, but they're more or less in the right space. So we are working in the performance space. I'm just haven't got permission to tell you exactly what we're working on. If you come and talk to me afterwards, I can probably reveal a little bit more. But for the pedagogical purposes, I'm going to say we're talking about specifically about detecting constructive feedback as part of this work. It doesn't really impact the key messages we're talking about anyway. Okay, so data annotation, everyone's favorite topic. So this, you know, everyone likes these quadrant charts. You know, there are different kinds of problems. You've got problems, you know, starting at the bottom, we've got things with low business value, that things you can't, you know, sell to customers and make money off. You know, we're a product company, want people to buy our things. If it's, you know, if it's got low business value and also you can't get your training data for free, you're probably not going to bother doing it. That's an easy one to discard. If you've got lots of training data, it's a really cool, interesting problem, but you can't sell it, then you're probably going to be unlikely to prioritize it as a thing that you actually spend some time on. There may be really interesting problems if you're working in academia. I don't know how many people here are working in sort of that researchy space, but for a product-focused company, that's not generally a thing that you work on. And like the top right, I mean, top right's kind of the golden quadrant, right? Like if you have, if you've got some training data that's already there, but yet you can also leverage it and turn it into a training data for a feature that's got really high business value, then you should probably do it, right? Because you don't have to do this sort of expensive annotation process. And you know, there are a few ways you can do that. It's kind of it sort of seems odd that you can do this in many ways, but when you get into it, you find that there are often ways that you can leverage existing data. So maybe I think customers have been doing a really boring manual task, and you say, okay, we can take that boring work away from you. You know, we have some things like that at Culture Amp that we might consider doing at some stage. Or there's external training data you can get from another source. That's sort of interesting in a competitive space, because if there is external training data, then potentially your competitors are going to buy that same external training data and build the same feature. So you're not going to, it's hard to get a competitive advantage if it's publicly available data. And also if you have if you've deployed a really crappy model and then you've let users leave feedback on that really crappy model, you can then of course use that feedback on that crappy model as training data. But the next best thing, and it's in some ways more fun, is this top left quadrant here. You know, a lot of novel problems we haven't tackled before, we're simply not going to have training data in our data set. And I anecdotally, it feels like this happens more in NLP than with sort of numerical and quantitative data. I don't know if that's actually true, but it seems like seems intuitively true to me that a lot of NLP problems, because you want to do some classification on a chunk of text, for example, you often won't have that classification on a chunk of text in advance. yes, that's what I want to say there. Okay, so we're sort of resigned to the fact that for this particular problem we're interested in, we're probably going to have to do some data annotation ourselves. What do we need to do that? Obviously, we need some data. But it's not just that you have some data. Obviously, it's more complicated than that. You need at least enough data that you can annotate enough. You have enough that you can annotate the trainer model. So if you need 1,000 training instances, you're going to need 1,000 pieces of actual real data or real looking data that you can do manual annotations over to get your training data. Secondly, regarding data, of course these days with NLP, we're often using sort of transformers-based techniques. So you're often in an even better place if you have a large quantity of just unannotated data, because you can use that to help tune your base language model to adapt to your domain better. But the real minimum thing is just having a couple thousand instances to actually annotate. Of course, the other part you need is annotators, which is not always so easy either, especially for annotation tasks that require domain expertise. And there also may be restrictions on who you can actually show the data to, of course. I'll talk a little bit more about that in a moment. So, of course, if you can avoid it, don't annotate. It's quite frankly can get very boring, especially if you're, annotating the 1500th instance in a annotation sprint. Oh yes, and sorry, here's a Slack post from one of the editors we had, who was very, very overjoyed to have completed this round of annotation. So we need to recruit these competent annotators. We've got to go through multiple rounds of creating and refining annotation guidelines. We've got to make sure that if we've got multiple annotators, they more or less agree with each other. And then just actually do the tedious annotation task. And then we'll probably still maybe not have enough data. Our model won't be converging well enough. So we're going to go back and annotate some more. But it's also just what we have to do for interesting problems. And I think it's not always covered particularly well in ML courses that I've seen. It's they often tend towards download a Kaggle data set for obvious reasons, but the nuances of actually getting the annotation right is kind of an important thing to do. And okay, so we need to do some annotation. Where are we actually going to do the annotation? Spreadsheets is often a solution that people use. They are the sort of the tool that you often use in sort of data sciencey tasks, because you can just chuck some data in there, and they're nice in that regard, but also they're kind of terrible in many ways. They're just good enough for the job a lot of the time. For here, we're not actually going to use that. And one reason is this one. The data we've got here is potentially, this is made up, by the way. It is not dissimilar from a comment I got when I was a hospitality worker at the age of 19. So the information in these performance reviews is quite sensitive to the subject of the reviews. So we actually want to, even compared to a lot of the other data we have, like survey comments, it feels intrinsically more like something we need to protect. So once we start putting it into Google Sheets and sharing it in a lot of places, then there's a lot more chances for data leakage, which we want to avoid. And from a reputational perspective, the data that we have is basically where a lot of the fact that we look after that data well is kind of the main reason the culture trap exists. So if we are not careful with that data, then we risk losing a lot of customer trust, and then they go to find some other employee experience provider who is more careful with the data. So we have to kind of respect customers' expectations. It's very easy, as you can see here, to get pushback against sharing and bad publicity about sharing sensitive data with people who are like not in the sort of inner circle of the company. And finally, there are sort of technical compliance reasons. We basically have to be very careful with the data. Like a lot of companies that are getting up to Culture Amp's size, we've got sort of 800 employees or so, sort of mid-sized company, but we want to have lots of enterprise customers. So we get this thing called SOC 2 certification. It's a security certification that says you're careful about lots of things, security and availability, I don't know. But we want to make sure, for purposes of SOC 2 certification, again, that we're doing all the right things with handling all this data. And so that's sort of reasons why we kind of can't annotate in spreadsheets, but there are also kind of technical reasons why we probably shouldn't annotate in spreadsheets. We can make our future selves happier if we put the data in the right place in the first place. So you know, we don't store our code in unversioned text files and email them around to each other. We usually store our code in a version control system. So having an appropriate data store for annotations also makes a lot of sense, rather than having spreadsheets that have been renamed 20 times because we've added some new rows to it or whatever. And like and if we had it in some external Google Sheet, we're going to have to you know, then sync it into a place where we can use it to do interesting training anyway. If this is a living data source, we're going to have to repeatedly sync it, and you know, having to repeatedly sync things is a whole minefield of annoying problems that you really don't want to have to deal with. And for training especially, we are potentially going to want to join it against other interesting user data, which is definitely not going to reside in Google Sheets. So our user data is living in a particular place, and so why not have our annotations live in that particular place? That particular place is, of course, the data lake. Lots of companies, lots of product companies have these days. This happens to be how Culture Amp's one is set up. I think it's a reasonably standard architecture. So we have our production user-facing services over on the left there. We've got web apps, microservices, or monoliths. They've all got, you know, there's a bunch of different databases. We have those databases feed into an ingestion pipeline that do lots of wrangling of that data, pulling it apart into different shapes, convert it into basically some flat files, and we put it into S3 on Amazon. You know, just have a bundle of these, a bunch of these JSON files or Parquet files or CSV files. And then we use the technology called Athena, which is a rebadged version of Presto that people may have used as well. That it's basically a database designed for this exact purpose, to look at flat files and give you an SQL-like interface on top of it. So you can do all kinds of fun data scientist type tasks. That's why I've got that picture of that happy data scientist over there. And also that's where we run our back office automated processes that do other interesting sort of data wrangling processes that we want to do on a periodic basis. So if you you know, coming to this from a place that doesn't use data lake, like, you might wonder why you do it. You could just query the production DBs, surely, but you know, yes, you kind of can. There are various reasons why you don't want to, and the nice thing about this is you can get the data into a shape that's much more useful and denormalized for your querying and for your ad hoc querying and other needs that you want to do that aren't that your product databases may not align well with. So when we use this this annotated data that I've been talking about, we're going to probably feed it into a training pipeline at some point. So that training pipeline is going to become one of these back office automated processes, basically. So it's just another reason to have this data sitting right there in the data lake. So you know, one part of this project, we've just built the simplest possible annotation UI that actually just puts the data in the right place from the start. So you not in a Google Sheet, but literally just in the same data lake where all our user data lives, where the data we're annotating lives. The boring but important detail is we've linked this into an authentication provider, and that's one of the ways we maintain SOC 2 compliance, keep our security team happy, because we Okta, which is this authentication provider, we have an audit trail. We know which users have access to this thing. It's only a very small handful of users, and we can revoke that permission whenever necessary. So it's the most compliant way we can give a small cohort of known people access to this highly sensitive data. How am I going? Okay.
You're going to talk about ish?
Where does it say ish? Oh, it is actually. I think that's the wrong place to put ish. It is robust. It is not a. It's not a pleasant user experience. I will talk more about that on another slide. Actually, I'll come back to it when we show the actual thing. I don't want to point the finger of blame, but it's actually all Athena's fault. Okay, so that is kind of the structure where we do the annotation. We need to recruit some annotators now. So the kind of annotation task we're doing requires a nuanced understanding of what makes for good or bad feedback, and how feedback be constructive, and all these other characteristics we care about. So it's not a simple, you can throw any untrained person, like an untrained human, at the task. It's not like identifying buses. We need people who actually are sort of domain experts in the space. So this is one of the reasons we can't just throw the problem at random people on Mechanical Turk, even if we were allowed to. You get well-known problems there, like having bad faith annotators who don't do good things. Even if they are good faith annotators, they probably can't do the job up to the standard that we need, and there's going to be some ramp up time to learn what our annotation guidelines actually mean. Just there's a bunch of legal and ethical reasons why we don't want to, as I said before, we don't want to sort of put the data and all these in front of a whole bunch of other random people, like the Apple Siri contractor news article I was showing you. It's quite similar to that. And finally, like, this data is actually, even if we wanted to try hard to de-identify it, text data is notoriously hard to 100% reliably de-identify, because you mention someone by name and they're the only person with that name at a company. Put together those two pieces of information, you can identify that person uniquely in the world. So if your name stripping happens to miss that name, then you've revealed the identity of that person effectively. So the annotators we chose, like CultureAmp isn't actually an expert in the. CultureAmp has a lot of expertise in the feedback space. It's kind of the reason we exist. We have a lot of people scientists or org psychs, as you call them if you're not at CultureAmp, who have all this domain knowledge. So we recruited a few of those org psychs to actually do the annotation here. The annotation process, like, how do you actually start? Like, with a lot of annotation tasks, you have a needle in a haystack problem. Let me just pause that GIF so it doesn't keep moving. Where you have a big chunk of data. The things you're interested in are probably in there somewhere, but how do you even know where to start looking? You probably don't want to read through 1,000 comments to find a small number of constructive ones. So these needle in a haystack problems happen to varying or lesser degrees in NLP problems. If you're doing sentiment annotation, you can probably assign a sentiment to most sentences that you see, so you don't have such a problem there of just finding the positive cases. At the other end of the spectrum, you've got one which I worked on with Antonio quite a few years back, of looking for mentions of medical conditions on Twitter, right? And that's real, like, maybe one in 10,000 tweets have one of these things. So you need to narrow them down before you can start your annotation task, right? For this particular thing that we're doing here, it's probably somewhere in between those two extremes. It's definitely not 1 in 10,000, but you don't see it at a sentence level. You don't see these kinds of feedback we're interested in as positive instances at the every sentence or two level. So how do we actually get there? If we had a bad model, we could use that bad model to start looking for things. But at the start of this, of course, by definition, we don't even have a bad model. So you come up with a heuristic to kind of stand in for a really bad model and use that to pick out some seed sentences you can annotate and feed them into a model to retrain that model, and then bootstrap the process. So your first round model can feed into your second round annotation, and your second round model can feed into your third round annotation, and so on. So you can keep repeating that for as long as you want. So going back to the annotation UI, it's beautiful. I'm sure you'll all agree. This is what happens when you get an ML engineer to build an annotation UI. I think it's not more ugly than a spreadsheet. I consider that a success, but also the ugliness doesn't really matter. What we need is a thing that does the thing that we care about. So we want to allow the annotators to submit binary classifications at the sentence level. That's another important thing. We optimize the annotation process here. Previous annotation things I've done, if you have to start making decisions about where a span of text starts and ends that is relevant to a particular thing, it becomes, it adds a lot of cognitive load to the process, because you have to think about where does the boundary lie. If we pre-split something into sentences, for this particular task, we don't lose very much. So we can take some burden off the annotator. So just, here is a sentence, tell me if it's constructive or not, basically. So you can click the button and it gets pushed to Athena. This is where the robustish thing comes in. Athena is not, to be fair to Athena, it is not actually sold or designed as a backend for interactive applications. It's a thing to have in your data lake. And so this is the biggest weakness of the solution we've got here, is we're using this non-interactive thing for an interactive purpose. I've just reached my step goal. The latency can be undesirably high, basically. We have to do a bunch of join queries to produce the sentences that we put in front of annotators here, and they can just take some time. Doing some pre-computation helps, but still you get 10-second page load times, which you would not accept for a user-facing application, but it is fine for annotators. We have 20 items per page, so it's not terrible. It has not actually forgotten annotations before, so it's doing its main job. And yes, yep.
Did you build versus buy?
I mean, we looked at ground truth, and it didn't have it didn't tick the security boxes easily. It was not as easy to integrate with at least our configuration of Okta, and this there were a couple other advantages. This gave us a bit more flexibility, and also it's not horrendously overpriced, because once this is built, it's free. Like ground truth has high ongoing costs, surprisingly high ongoing costs. Okay, so how do we actually just walking through the annotation refinement process? This is if you have to do an annotation task, usually you have to go through this process where you write some annotation guidelines, what you think it is you're trying to annotate. You need to then actually try those annotation guidelines out. You have multiple people go and look at the thing and annotate the data according to these guidelines. Then go, okay, let's measure the inter-annotator agreement. Is it okay? It will probably not be. First time around, it almost certainly isn't. So then we go back, we analyze the discrepancies, spend just way too long arguing about them. It's hard to avoid that. ideally resolve the discrepancy. So you've got a canonical truth, and then use that to feed into revised annotation guidelines. It has a secondary effect of actually solidifying more of the kind of implicit guidelines in the minds of the annotators, because there are some things that's very hard to codify, and it's just kind of in people's heads. So you try and codify everything you can, and the stuff you can't is kind of just in the annotators' minds. So ideally, all the annotators you have can be involved in the resolution process. And by the way, that's why I've got this conflict resolution mode here, which shows up red bits when you disagree with other annotators, which was useful for that calibration process. We measure inter-annotator agreement, inter-annotator agreement, which is similar. I mean, the accuracy is hard to measure because you don't know which annotator is right if they disagree, right? But we measure the agreement using a few different metrics. One's called, the data science the team was doing this, Krippendorf, whatever, the alpha, yes, Krippendorf alpha. Or you can also measure the basically the F score of an annotator against another annotator. Yep.
What your pool of annotators?
What was the pool?
The pool of annotators, where the annotators come from?
They're from various parts of CultureAmp. So there's some internal team. Yeah. So before the reason outline, like we didn't want to share it externally, so we recruited some org site people, some people from other parts of the company. Tried to make it as diverse a group as one. Sort of neurodiverse people, like not all. In fact, no white men. So that's an exciting change for a tech company. Or actually on the core annotation team. Oh no, there was one. Yeah, but a diverse pool of internal annotators that had sufficient domain expertise. Okay. I am going slower than I did my run through, but we're getting there. All right, NLP. Who likes NLP? Maybe lots of people in this room. I'm actually going to briefly talk about some actual NLP rather than all the stuff around the NLP. But I don't want to get you hopes up too much. It's not super involved or interesting. Everyone likes Hugging Face these days. I hadn't used it until recently because I've been not in the NLP space for a couple of years. But I can report that everyone's right. It is quite great. It's got good developer ergonomics, like as few ones as possible to set up a classifier. You don't have to worry about any stuff that you shouldn't have to worry about unless you want to. It has a bunch of base pre-trained language models that you can choose from. The problem that we're doing is actually pretty hard, and it's like probably harder than the constructive example I've been lying to you that was the actual problem we're solving. And we're getting respectable results across actually a few different types of models, 0.65 to 0.8 F score, from only a few hundred training samples. Like for a problem that hard, I'm actually quite impressed by how much you can get. It's amazing what those base language models buy. And like the performance is good as well. We can get sub-second inference on AWS, so we're not concerned about high latency if we roll this out as a customer-facing feature. So yes, like nice experience there.
Are you using SageMaker?
Yes. I not always pleased about the decision, but we are using SageMaker at the moment. Yes. All right. So just to make sure you get your money's worth, I need to put up a slide with a totally unfounded assertion on it that's absolutely contradicted by my previous slide where I just showed you some model metrics. So take this out of context and have whatever fun you want to with this. It is obviously a gross simplification. Model metrics do matter, but like having like the thing that matters, more, model metrics is not the only thing that matters, I guess is the key thing. The thing that matters for users is the perception of the end-to-end experience of the product. If you have terrible metrics, then the end-to-end experience of the product is probably still going to be terrible. But if you have a terrible UX, also the end-to-end experience is going to be terrible, even if you've got really good models backing it. And if you've got a good UX, you can potentially make a bad model seem less bad. So these sort of things need to be considered end-to-end. Like metrics are really good for us as an NLP team to optimize stuff before it gets in front of users. But that's kind of not the end of the journey. So we've got to design the end-to-end feature around presenting the outputs well, and often I think you want to optimize for higher precision to have less chance of putting wrong things in front of users. So if you're not sure, maybe don't say anything to them. But that whether you can do that depends on the feature you're building, of course. Yeah.
Sergio Rodriguez asks, are those F1 scores, are they out of the box first, or have you further trained it with your data?
Yes, it's further trained with our data. And also, hello, Sergio.
Hello, Sergio. You can't hear me. You can hear me.
Yes. So what was I?
Hello.
So we want to we need to have good feature design to actually receive the outputs of the models, and not just kick a model over the wall and go away and say, all right, that's it. You go and do the UX. We've done our job. Like it's still got to be a collaborative process, which we're working out how to do as culture with our team structure, the complex subsystems NLP team. And then the other thing that a lot of people have ingrained if they've built ML features before, and it's very easy to forget though. Even if you're building crazy complex models, there's still most of the work of getting a feature in front of end users is all the stuff around that. A bunch of time writing JavaScript and backend code to interface with the API backend, all those kinds of things. So 50 or 80% of work is just nothing to do with the machine learning at all, even if it's a machine learning backed feature. I think the interesting part, the difficulty with ML projects is often not that they're substantially harder, like you don't need heaps more work to get them done necessarily, but you do have a lot more uncertainty before you start the project about whether it's even viable, which is really, really troubling for product managers. Okay, I am going to stop talking soon. Repeatable training. Repeatable training is really important. I need to have some conversation with Beck about this at some stage. So quite a common use pattern for data scientists to try and improve their models by doing rapid iteration in a kind of Jupyter notebook type environment. That is good for rapid iteration. It's not great for several other things. For repeatably training things, a notebook is not usually an easily executable thing you can use for repeatable training. It's not necessarily great for collaboration either, unless you're very careful with how your notebook is set up. You don't know that your colleague will be able to, run it in the same way. So what we have not done particularly well in this project so far, but are actually working towards, is getting more towards reproducible training. Use the principles that software engineers have been using for a long time, MLOps type things of, we put our repeatable training code and run it from a continuous integration pipeline so that our model gets to the place we want it to get, and we know that it will be trained without lots of manual work from a data scientist every time you want to update the model. And we want, if a data scientist finds a way to boost our F-score, we want to get that model into production sooner rather than later. I won't go into, this is the way we're working towards for actually doing this.
One question.
Yep. Mm-hmm.
I mean, if you try to work 10 times, likely you have 10 different steps, right? So it's not just about modifying the CI/CD pipeline and make a result. It's also about model development as well. How we reduce the kind of like a stable and deterministic training.
Yes. I mean, I think there's yeah, there are some of those considerations we haven't run into yet, but just having setting the same random seed each time is a good starting point. If you do that in theory, then every setting the same random seed. If you train off the same data, then you should 10 times. You shouldn't get 10 different results, right? We should get,
unless you're doing parallel GPUs.
really. Okay, cool. Good to know. I probably won't do that. So we've started pulling our core training code into a shared, and carefully engineered code base, and we can pull that code base into an automated training pipeline and push our models in all kinds of places. Don't worry about all this SageMakery middle stuff. But the key thing is we're using that same code, we import it into a notebook environment and use it to experiment on, make changes to that to experiment on it and iterate that way, but then commit the changes back so we can redeploy the model when it's done. Our team is getting better resource now, so we're probably going to do this, kind of building this stuff from an earlier stage. Now we have more than one engineer who's doing a lot of different things, but we're getting there now. Okay. Other considerations, you want to know if your model's drifted, if it's no longer performing as well as it once was. There are various ways you can go about this. Assuming you don't want to avoid annotating more data as possible, which you probably do. For us, the things we plan to monitor are how many times we make suggestions per sentence. If the number of suggestions is going up over time or down over time, something is changing about how that model is being applied. So we may want to consider looking into it and seeing why that prediction rate is changing, basically. Secondarily, we can also look at because we are wise, we'll make sure we've built in a feedback facility to the feature when it's deployed. We're very, I've been very adamant that we put that in from the very start, learning from previous mistakes that we've made at Culture Amp. In fact, you want the feedback mechanism as early as possible, so then we can use it as another signal to see if the model's performance is degrading or maybe getting better. Who knows? Probably degrading though. Another thing that's top of mind, which we again haven't done anything on, is just making sure that it's fair and equitable across different cohorts, because that's another way that you could have not necessarily temporal drift, but different performances based on the characteristics of the demographics of the people involved or the companies involved. So maybe our rejection rate is much higher for the construction industry, suggesting they use different language in performance reviews in the construction industry towards then the kind of new tech Silicon Valley startup that makes up a lot of our customer base. That's a lot of our training data has come from those kinds of customers. So whether it generalizes across industries is an interesting question. Yes.
How do you do that? How do you ensure the
ensuring is really hard. At least measuring for it is, I think, reasonably straightforward with our data. So the way we would measure this and produce this graph, we will store all our predictions in the data lake, record every prediction that's done. We'll know the identity of the user. We can then join that in our data lake to demographics of the company, like the industry being the construction industry, or the review agenda. We actually we generally know that as well. It is surprisingly hard to know that because of how our data comes in, but we do actually usually know the agenda of the viewer, so we can then stratify by any characteristic we're interested in and produce the look at the different rates at which these things are done. So the ensuring that's the hard part, of course, is how do you once we've found this out, what's the action we take? That's hard. If we're doing if it's performing worse particular cohorts, we could use the rejection information in a retraining cycle and weight those the rejections from those cohorts more highly potentially. But yeah.
use to target bias?
Do you mean sort of not at the statistical level, but
Yeah, I mean any specific algorithms you use to identify the biases, or it's just looking at an
yes. So yeah, what I'm talking about here is purely like the first part, reasonably simplistic statistics based on those joins. So yes, I think you're probably talking about you're probably thinking like 2 steps ahead of what I'm thinking about here, of like how do you do it really well. And I'm thinking, how do we do it at all, which would be the simple and dumb thing. And I think if I talk to the data scientists in my team, they'll probably have lots of other better ideas than I've had on this so far. Yep. I mean, they didn't act on the advice. So what I'm using it to mean here is that they in the interface, which I haven't showed you, there's a thumbs down button where we say this advice is wrong. Basically, you're similar to the whatever you get on various things you probably use. You've seen this, like literally, like I'm so mad about this, I'm going to tell you it's wrong. What you're maybe talking about is a kind of softer rejection, which is that you basically ignore it and you write some feedback. It says you should make this more constructive. You say, I think it's pretty constructive already, but I can see why you told me it wasn't, but I'm not going to tell you it was wrong. I'm just going to move on and ignore it. And so that's a different category which we could also look at. But we're what I'm thinking about here is the hard, like, I really hate this, so I'm going to push the thumbs down button and tell you. I mean, another interesting thing about the rejection, of course, is that a lower rejection rate doesn't necessarily mean that it's working better. It could be that people are, over like willing to accept the feedback and just ignore it or act on it, even though they think they shouldn't act on it. So it's a noisy signal, right? And it could be different for different demographics.
Do you have the gender of the person being reviewed?
We have both, yeah. So we get a lot of information from HRIS systems, but it's sort of basically free text fields. We have to do some work to map it to what we think are actually gender fields for a standardized analysis. But most of it comes in from most customers. I think we've got like 80 or 85% coverage of gender across at the user level. All right, I mean, I'm going to basically wind up. I think I've covered most of this already. Like, we will want to retrain at some stage, and we ideally retrain without using the training, like without having to annotate more training data if we can. So these signals we've talked about of rejection rates is probably one way to do that. Sort of related to that other question, actually, like another thing we can potentially do is look at, if someone, if we suggest an edit and someone does make an edit, and we then go, okay, yes, we accept that as, we're now classifying this text you've entered as constructive. That's probably a strong signal that the classifier is actually doing something correctly, because if humans added a thing, we think it's constructive and it wasn't constructive before. So that's probably a signal that we can use as a positive data point in our sort of our retraining pipeline as well. All right. So takeaways. This was very much a grab bag of things that are front of mind, because I've just started working on an NLP project again, and I was excited, and we didn't have a speaker for today, so I put my hand up. But if we can come up with some takeaways, like annotating data straight into your data lake is nice. I do recommend it. It's a kind of an NLP superpower if you know how to set up gnarly annotation tasks, even if you don't want to. And like, as I mentioned a few times, like we want to make sure you put the feedback feature in as early as possible. Don't leave it as a thing to follow up on, because in a busy product company, you never follow up on it. And you'll be very sad a year later if you haven't got a feedback feature, because you won't know if your model is drifting. You won't be able to get any training data, like free training data to retrain your model when it is drifting in a year's time. Okay, that's all from me. Do we have any more questions? Not yet. That will be interesting. I think that's probably the sort of thing you might do when it's the feature's been out for a couple of years. If you get uptake, but you find that it is working differently for different companies or classes of companies, you could use that feedback data to retrain company or group specific models. But in the first pass, we're doing a global model for simplicity. Yeah.
So has another question. Is there a question in there?
Oh yeah, so just following up on that.
Yep.
So do you balance the basic, different companies somehow? Because there is definitely distributional shift, right?
Yeah. So that is a good question. I need to ask the. Do we balance the data from different companies for the training, the annotated data, right? Yeah. We created that seed data, and the data scientists in the team created that seed data, and I cannot remember what kind of sampling methodology we use. I think probably not explicitly. We pulled out like interesting instances according to the model, but we haven't sort of strived to get a good cross sampling of companies there. So yeah, we probably should have, but yes, like if we come back to representation and if we get like training data from the rejection advice, that's another thing to consider of like balancing across those companies. That's good point, good question.
I was wondering about the interesting instances according to the model. So is there like, do you like use a language model to pull out instances that are somehow in domain?
Yes, so what we use the we iteratively use the just the model that we've trained for the specific annotation task to provide to get high confidence, medium confidence, and low confidence instances to look at. Yeah, exactly. Yes, it was like half-baked active learning, basically. Yep.
So 2 questions.
Mm-hmm.
If you do all this again, is there anything you do differently?
Oh.
And then what's the next step?
Yep. All right. 2 good questions. What I would do differently is try to get the reusable training code implemented earlier. Like the longer you leave data scientists working in notebooks, the more code you have in notebooks. And so the early, like if we had enough engineering resources, we could have sort of we know that the data prep is working. Let's pull it out to a function now, and then you can just use that. You're probably not going to be touching that much, and if you are, we have a way for you to do that. So that will be the main thing. Anything else?
Would you use Athena, or were you looking at?
Oh well, yeah. Like we're stuck on Athena for the data lake in general. It would be there is some like we actually do use Redshift in the business. There is some boring reason why we can't use it in the data lake. I cannot recall what it is. If it is lower latency, I would love to try it out. But yeah, like I mean, essentially, like if we're dumping our annotation files as JSON or S3 into a into an S3 bucket, our JSON or CSV or whatever, like we can point different query engines at it anyway. So we're not married to Athena, but it is yeah, it was the quick tool to get the job done for now. Sergio, can you describe your thought process about framing this as a binary classifier? Did you consider a different framing, for example, a regression model? So for the For the annotation task, we're obviously going to set it up as a binary classifier for the ease of annotation. It doesn't seem to be an inherently sort of regression-like numerical problem to me, but we are actually, we're looking. Obviously, we do get a numerical score out of Hugging Face anyway, which we're actually using to as a way to adjust thresholds. So no, I didn't consider explicitly framing it as a regression model. We actually have more than one binary classifier, also full disclosure. Like there are several facets of the performance we're looking at. That's kind of related to your question, Sergio, about binary classification. So we are treating it as several independent binary classifiers. We've probably also could look at making it a multi-class classification problem as well, because there's probably some similar characteristics between the different different classes that we've got, and some relationships between them. So I think there was one second question there that I maybe haven't answered.
What's the next step?
What's the next step? So we are looking at when we're going to turn this into a product, and we're basically, finding out when the team that does all the really important UX work I was talking about actually has time to do it, making sure that we're tracking all the right things from the API side when that happens, but also considering what's next, like, because we've done most of the work on this, so there may be some background work and kind of productionizing from our perspective, but we're looking at other stuff in the engagement comments space that I was talking about, the comments left on surveys potentially, but what we're going to do there, we're actually not sure yet. So, yep. So in front here, I think you were first. The blue shirt. Oh, either.
Sure. Do you do any data burdening, and how do you track experiments?
Yes, not as well as we should. So they are, like, both better experiment tracking and better data versioning are works in progress, and so it's an ongoing, like, working with our one data scientist to work as a better practice. We, as I mentioned, we're hiring, so we're going to have 2 data scientists soon, so that data versioning experiment tracking is going to be even more important. We've started evaluating weights and biases and ML flow as tools that do some of those things, but we haven't got to the place I want to get to yet for that. Yeah.
Massimo says thank you.
Oh, thanks, Massimo. Yep.
Maybe you already started touching on this, but if one of the sectors, the language is too different from all the others,
yep,
how do you deal with this? Do you do a separate model for that, or do you
yes, well, I think we would. So if we do these kinds of different industry analyses, and we find that's a problem, then we'll address that when we come to it. If it's bad enough, we might say, all right, we're going to turn this feature off for this subset of companies if we're too embarrassed about how it's doing. But probably it'll just be that it's slightly worse, and it's a business decision about how much we care about that and how much we want to come back and focus on it, and whether we can roll it out enough to get the rejection information to use to improve the models for those things. Yeah, like I really interested in building like company and industry specific models in general, like for lots of stuff. I think it's a cool, interesting problem to do, but we're not quite there yet. Yep, Dan.
Yeah, sure. I saw that was it right, you're using Distillbert from Hugging Face.
Yes.
What's the thought process? How do you decide which one? And also, like, if you're running experiments to determine like whether using a different language model would improve it.
Yep.
Is that something you consider? And also, like,
yes.
Do you think about runtime latency as well?
Yes to all of those. So, well, the first one wasn't a yes/no question, but I think Distillbert was actually the first one we tried, and it provides reasonable performance. One of the factors was, in fact, that we would be able to get reasonably low runtime latency and really fairly low memory requirements on the instances that are serving it up. So that was a good starting point. And we haven't yet gone back to try other ones, but we will treat that when we do that, we'll treat it as a parameter to the model and just log the parameter and see how the S scores look afterwards, basically. But yeah, I think the silver is often a good starting point because it's gets lots of the benefits of a large one, but compacted. Yes, hello.
I've got a question. So you mentioned that annotation is an expensive process, right? It's costly.
Yep.
And of course, the more annotated data, the better.
Yep.
Generally. So for your problem, how do you decide how much annotation minimum is enough?
Yes. So we've actually been creating, building up learning curves from the taking slices of the data as it gets annotated and seeing if our F score has plateaued as we increase the amount of annotated data. And it's been surprising actually for some of the models we've been training. Like we've probably actually done more annotation than we need. We're not getting substantial boosts in F score from we've been doing it people do a day of annotation a week, and the last couple of weeks we probably didn't need to do for some of these models because we're already getting a 0.8 F score for this model. From week 3 we didn't need week 4 and 5. Others are still going up the curve. But yes, we're basically just doing the time slice and plotting how it increases as you increase the annotation volume over time, and so trying to decide. It's the curves do tend to jump around a bit as well. So it's not, you don't get nice neat, oh, this is definitely plateauing here. You get sort of, oh, there's a bit of noise and there are large error bars there, but it looks plateau-ish, so let's stop. But also, the business conditions dictate we kind of have to stop annotating now anyway because we're coming to a new half and maybe starting to think about new projects. So sometimes external factors decide for you.
When your annotators go on strike.
Yes, yes. Yep.
So for that process, how do you choose the testing data? Because you need to get the score from somewhere, right? And that should be diverse enough so that you can trust the score. If you for example, have 100 examples that are basically the same except for one word, right? So the score will probably plateau real quickly.
Yes. Yeah. So we.
Can you repeat the question for people?
Oh yeah, sorry. So the question, I'll try and play it back to you. So how do we ensure that when we're sampling the training data, that the training data we're sampling is sufficiently diverse? Is that?
I guess the testing data, because you just said.
Oh, the testing data, yes.
You use that to.
Yeah, got it.
You're plateauing, right?
Yep.
So how do you choose the testing data?
We choose the testing data is also annotated data, so we're choosing it in the same way as the training data and keeping a held out subset to use, but we're not paying particularly close attention to diversity. We're just ensuring that we've got an arbitrary repeatable ordering based off a hash. So yeah.
And does that apply to the sampling as well?
Yeah. Yeah. All the same process. Yep.
It's 6:13.
Yes. Should we call it there? I'll be around if anyone's got any more questions, wants to talk in person.
Let's thank Andy. Thank you.